This question says a ball is thrown upward and its height after t seconds is modeled by the equation h of t is negative 16t squared plus 32t plus 4. How many seconds must pass before the ball is 12 feet high? So it's not 12 seconds after it's launched, it's when the height is 12 feet. So what I need is I need h of t to equal 12. And I need to solve for t, how many seconds must pass? So if h of t is 12, replace h of t with 12, and I have 12 equals negative 16t squared plus 32t plus 4. We look at this for a few seconds and recognize it is a quadratic equation. Why? Because it's t to the second power. If I'm doing quadratics, I've got to set them equal to 0, so subtract 12 from both sides. So now I have 0 equals negative 16t squared plus 32t minus 8. Now, I could directly go to something like completing the square, but that's not real wise because I can simplify this significantly if I recognize that 16, 32, and 8 all have a common factor of 4. And I'm even going to make it negative 4 because that way I can start with a positive coefficient on t squared. So I'm going to divide everything by negative 4. Remember, that's plus negative 8 divided by negative 4. What that will give me then, more simplified form, is 0 equals negative 16 over negative 4 is what? Is 4t squared. 32 divided by negative 4 minus 8t. Negative 8 divided by negative 4 is positive 2, and recognize, hey, guess what? 4 was not the greatest common factor. I could actually divide by 2 again to make it even simpler. If I had noticed that the first time, I could have divided by negative 8 instead of negative 4. Let's do it one more time, and what do we get? We get 0 equals 4 divided by 2, 2t squared minus 4t plus 1. Now, this is what I'm going to want to use in the quadratic formula. So a is 2, b is negative 4, c is 1. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b, negative of negative 4 is positive 4, plus or minus the square root of b squared, negative 4 squared, minus 4ac, 4 times 2 times 1, all over 2a, all over 2a, all over 2 times 2. So we get t equals 4 plus or minus the square root. Negative 4 squared is 16, minus 4 times 2 is 8 over 4. So we get t equals 4 plus or minus the square root of 8 over 4. T is 4 plus or minus, now 8 is 4 times 2, so that's root 4 times root 2 is root 8 over 4. So t is 4 plus or minus 2 root 2 over 4. Dividing by 4, make it look a little simpler, I guess, maybe. T is 4 over 4 plus 2 root 2 over 4. So t is 1 plus or minus 2 over 4 is 1/2 root 2. So those are my two answers in exact form, 1 plus 1/2 root 2 and 1 minus 1/2 root 2. But it's a word problem, and I'd like to get an idea about how many seconds that is, right? So let's use a calculator to approximate those. So I want to see what is 1 plus 1/2 root 2 and what is 1 minus 1/2 root 2. So 1 plus 1/2 root 2 is approximately 1 plus 1/2 times the square root of 2. I'm getting 1.707. And then 1 minus 1/2 root 2 giving me about 0.293. Now the question asked, how many seconds must elapse before it's at 12 feet? So the first time it's at 12 feet is about 0.293 seconds. Okay. First time at 12 feet in height. Is 0.293 seconds approximately. That's on the way up, right? And then the second time at 12 feet in height is about 1.707 seconds. So that's on the way down. Now let's see if we can do this using the graphing calculator. So I'd like to pull that up if I can. So let's pull that window up. Here it is. So first of all, 1/2 plus 1/2 times the square root of 2. I just want to show you how I was able to get that. That should be 1.707. And then 1/2 minus 1/2 square root of 2. Whoops. So 1/2 minus 1/2 times the square root of 2 should give me my 0.293. And something's strange there. Okay. It's not 1/2, it's 1 plus or minus 1/2 root 2. So let me show you what I mean by that. Let's type in the wrong thing in. Right. 1 plus 1/2 root 2 and 1 minus 1/2 root 2. Let's go back to the calculator and fix that. So second enter pulls back previous work. So what I'm going to do is I'm going to just arrow this over. It's a nice little trick to see. And I'm going to delete this part if I can. The DEL button deletes one character at a time. So here's 1 plus 1/2 root 2 should be 1.707. There it is. And then second enter pulls back the previous line. Change that plus to a minus. And the minus is here. Whoops. Arrowed it over one more. 1 minus. That's what I wanted to say. 1 minus. Enter should be 0.293, and it is. All right, but I want to show you how we can actually solve this equation using the graphing calculator as our primary tool. Okay, so let's make sure we know what we're looking for here. So this is where we were previously. 12, the height, was negative 16t squared plus 32t plus 4. So I could graph them both, but I think it's simpler if I subtract 12 from both sides. And then I get what? Then I get 0 is negative 16t squared plus 32t minus 8. And I'm going to graph that. I'm going to graph this, negative 16t squared plus 32t minus 8, and find out when is that equal to 0. Let me show you. Clear this page. Y equals, and let's get rid of all of this stuff. We're going to go ahead and plug in that equation. I want to find out when is this equal to 0. So negative 16, the negative sign is here. Negative 16, I can't use t, I've got to use x. Negative 16x squared plus 32x. When I subtracted 12 from both sides, it's now minus 8. And I want to see when is that 0. I'm going to do a zoom decimal, although even that's going to be too wide. Which you're going to see here in a minute. Everything is very, very close. So I'm going to adjust that a little bit. I'm going to adjust my window. So I don't need nearly as much x. I need a whole lot more y just to get a feel for what the graph looks like. So I'm going to cut the x in half. And they need a whole lot more y. So I don't know, maybe multiply the y by 4. Let's see what that graph looks like. Okay, that's pretty good. And I want to find out when it is equal to 0. Remember, we wanted to find out when 12 was negative 16t squared plus 32t plus 4. When I subtract 12, then I get negative 16t squared plus 32t minus 8. When is that equal to 0? So we see that on our screen. I'm going to use the 0 finder to find out where does it cross here and where does it cross there. 0 finder, second calc, 0. Move the man in the spaceship a little bit to the left of where it crosses. Okay, there we go. That's pretty good. Enter. Move him a little bit to the right of where it crosses. Enter. Guess move it close to where it crosses. Enter. And it's giving me 0.293, which is what we had before, remember. 0.293 was our first guess for when it reaches 12 feet on the way up. To find the second one, second calc, 0 finder. Move the man in the spaceship a little bit to the left of where it crosses. This would not work if we had a complex number solution, nor does it give you an exact solution, which I had given to you earlier. So the other solution is going to be about 1.707. So that agrees with what we did before. But I still think the hardest part of this problem is setting it up, right? Reading the word problem carefully and determining what we're looking for.